Hello students, now in NEET 2017 I have the next 5 questions from 16 to 20. So now question number 16. The thermodynamic processes are indicated in the following diagram. Now diagram is given here. This is now your pressure, and here is the volume. On this side we are given 3 curves like this. Now this is the point from where this is now first process. Now then this is so much second, and this is third, and this is fourth. So now the question is, match the following. Match the following. P this is your column first, column second. Now this is P, process first. This is a adiabatic. Q, process second, and B is isobaric. C, process third. C, this is given isochoric. And PQ, this is now R. And then S. S is given process fourth, and D is given isothermal. This is the, and now the options are given here. Now first is the option is P2A, then Q2C, then R2D, and S2B. Second option is P2C, Q2A, R2D, and S2B. Now third option is P2C, Q2D and R2B and S2A. Fourth, P2D, Q2B, R2A and S2C. You have to choose that which of them is correct from first, second, third and fourth. So now the solution. Now process 1, the volume is constant. Process 1, B equal to constant. So this is the isoporic. Process. Now process second. In process second, the temperatures are also given here. This is how much? 700 K. This is your 500. This is now your 300 K. These are given. Now process second, the temperature is being changed. So temperature is being changed, it means that this is the adiabatic. Nothing is constant. So this is adiabatic process. And now you can have this process third. In third, this is going at a temperature of 500 K. So the temperature is constant. T equal to constant. Temperature constant means that this is now isothermal process. And now process fourth. In process fourth, the pressure is constant. This is now pressure is constant. P equal to constant. So this is now isobaric. So what we have? The process 1. Process 1 means this is now P. So process 1 P. So the isoporic means C. So this is now P2C. P2C, isoporic. Volume constant. Process second, nothing constant, adiabatic. Process second, Q, adiabatic. So this is now A. Q2A. R, process third, isothermal. Process third, isothermal. So isothermal is D. So R2D. Now then S. We are having the process 4. Process 4 is isobaric. So isobaric is here B. So B has to B. So this is the correct relation. And if you find this one, then P2C, Q2A, R2D, S2B. So our right option is second. This is our right answer. Answer is second. So thus by looking at what is the constant, what is not constant, by that you can find that the process is what? It is isothermal, isobaric, isoporic, or the adiabatic. This is now question number 16. And now question number 17. Question number 17. A capacitor is charged by a battery. Is charged by a battery. The battery is removed. The battery is removed. And another identical uncharged and another identical uncharged capacitor is connected in parallel. Is connected in parallel. The total electrostatic energy electrostatic energy of resulting system Now the options. First, increases by a factor of 4. Second, decreases by a factor of 2. Factor of 2. And third, remains the same. And now fourth, increases by a factor of 2. Increases by a factor of 2. Factor of 4, factor of 2. This is the question. Now the solution. Now the solution is that the capacitor is charged by a battery. So the initial energy U1 is equal to half CV square, B the potential difference, and after removal of battery. Now we can have since the two capacitors are connected in parallel like this, its capacity C. First there was the initial one, and second this was, and its charge. Now this Q1 is equal to Q and this Q2 is equal to 0. This was uncharged. So now we have the common potential. Common potential V dash equal to C1V1 plus C2V2 upon C1 plus C2. Now this is now CV1. This is now your V1 is equal to V, and here V2 is equal to 0. So this is V, this is now C2 into 0 upon C plus C. So this is your V upon 2. This is now V dash. So new. New energy U dash, or this you can take U2 is equal to half C V dash square, and this will be your U2 is equal to half C. Now V dash is equal to V1 whole square. So this is your 1 by 2 into C V square upon 4. So now you can have that this of both the capacitors half plus half C V dash square, because we are having 2. So this is now half C V dash V upon 2 whole square plus 1 by 2 C V square upon 4. So this is equal to C V square upon 4. This is now U2. Then change in how much? Delta U is equal to U1 minus U2. So this is now your half C V square minus 1 by 4 C V square. So this is now 1 by 4 C V square. So now we have to find the change. Now then delta U upon U1, this is now your 1 by 4 CV square, this is 1 by 2 CV square, this will cancel by 2. So this delta U upon U equal to 1 by 2 U1, or you can have this delta U equal to U1 upon 2. So energy will decrease. Energy will decrease by a factor of 2. So energy will decrease by a factor of 2. So our right answer is toward the second one. It is given that decreases by a factor of 2. So this is what to apply. That first we apply because the single battery, the single capacitor is being charged by the battery. So initial
energy will be half CV square. And when the battery is removed and in place of that a SIM capacitor is connected in parallel, then in parallel there will be the charge will be distributed. So find the common potential. Common potential is to this one. Then both the capacitors are in parallel. Just to find the energy of both and then add. This will be the final energy. And then find the change and then delta U upon U1. That will give you the right answer. Now question number 18. A physical quantity, the photoelectric threshold wavelength photoelectric threshold wavelength of silver is 3250 into 10 raised to the power minus 10 meter. The velocity of electron ejected. The velocity of electron ejected from silver surface by ultraviolet light of wavelength light of wavelength 2536 into 10 raised to the power minus 10 meter is now first option. There is given something, so here is given H equal to, this is equal to 4.14 into 10 raised to the power minus 15 electron volt second, and C 3 into 10 raised to the power 8 meter per second. This is given. Now the option is, first option is approximately 6 into 10 to the power 5 meter per second. Second is approximately 0.6 into 10 raised to the power 0.6 10 raised to the power 6 meter per second. And third is approximately 61 into 10 raised to the power 3 meter per second. And fourth is approximately 0.3 into 10 raised to the power 6 meter per second. These are the options. Here we shall directly use the Einstein photoelectric equation. Einstein's photoelectric equation. This is now your half mv square equal to h nu minus h nu naught. So this half mv square equal to hc upon lambda minus hc upon lambda naught. you are given this is not value of lambda naught, this is lambda naught, this is the value of lambda, this is given to us. But here is given that H equal to 4.14 10 raised to the power minus 4 electron volt second. This is expressed in joule second. So in joule second, joule has been converted into the electron volt. So this is the value of so much. So this you have to use it, and then you can find that this is equal to your 1242 electron volt nanometer upon this is now your 3.6 electron volt. Sorry, nanometer. This is not nanometer. This is minus 1242 electron volt nanometer upon this is 325 nanometer. We have converted this into a nanometer, so 0 will cancel the 3 to 5, and here this will be your 35253.6. Not so much. So now you can change this nanometer to nanometer, and this we will get this in electron volt. So this will be equal to 4.89 electron volt minus 3.82 electron volt. This is equal to half mV square. Half mV square. So now then you find it. अब इसमें आपको V का मान निकालना है. So V इक्वल टू इसको घटा देंगे तो ये, और घटाने पर इसकी वैल्यू आ जाएगी 1. This is now your 2 into 1.077 into 10 raised to the power minus 19 upon 9.1 into 10 raised to the power minus 31. This is now square root of so much. So now you can calculate and find this one. So this will come out to be approximate 0.6 into 10 raised to the power 6 meter per second. Calculation is somewhat tedious because you have to multiply and then divide and then find the square root. So this is tedious calculation. So if you know it better, this you could calculate so much, then you can find the answer. So you can see that here this 0.6 10 raised to the power 6 meter per second and 6 to the power 5 meter per second, both answers are equal. So either you take first or you take second, both the answers are correct. Answer first and second, both are correct. Now question number 19. Question number 19. A physical quantity of the dimensions of length that can be found out of C, G and E square upon 4 pi epsilon naught. Epsilon naught is, अब इसने एक दिया है कि C velocity of light and G universal gravitational constant. G is universal gravitational constant, and E is electric charge, and E is electric charge. This is given to us. Now the options are, first option is 1 upon C square into G E square upon 4 pi epsilon naught. Epsilon naught raised to power half. Second option is your C square bracket G into E square upon 4 pi epsilon naught. This raised to power half. And third is your 1 upon C square into E square upon G into 4 pi epsilon naught. This raised to power half. And fourth option is 1 upon C G into E square upon 4 pi epsilon. This is now given. So you can see from here that dimensionally we have to find it. This is now use of dimensions. So we say that let physical quantity that we take it to somewhat Q, and the dimensions of C, G and E square upon 4 pi epsilon naught are A, B and C respectively. These depend upon these dimensions. So now what we have, that this Q is equal to, now this C, this is raised to power A, G raised to power B, and this E square upon 4 pi epsilon naught, this depends upon the power C. So now we have to find. Now C and G, the dimensional formula. Now this C, this is your L1 T minus 1. G is equal to and that this E square upon 4 pi epsilon. This is the formula from the Coulomb's law. K Q1 Q2 upon R square. K equal to 1 upon 4 pi epsilon naught into E square, and then this will be F into R square. So F into R square. So this is your M1 L1 T minus 2 into L square. So this is M1 L3 and this is not T minus 2. This is the dimensions of this one. So now you put all these. This is the dimensions of length. So this is L equal to this Q is dimensions of length. So this is now your C. This is your L1 T minus 1 raised to power A into G M minus 1 L3 T minus 2 raised to power B into this is now your M1 L3 T minus 2 this raised to power C. So now what we have? This is your M0 L1 and this T1 T0. So this is your M A minus B plus C. A B, sorry, this is not B. Minus B plus C. And this L, this is A, this is now plus 3B, this is plus 3C. And T, this is now your minus A, minus 2B and minus 2C. Now compare these powers of M and T. Comparing M, L and T. What we have? This minus B plus C equal to 0. So this gives you that this B equal to C. Now this A plus 3B plus 3C, this is equal to 1. This is now equation number. And then we have this minus A minus 2B minus 2B minus 2C, this is equal to 0. So now B equal to C. Now put this value in this one. Then from to this, so we will have this. Now we put to this A plus, this is now your 3B plus, this is now your 3B. So this is equal to 1, and you will have this A plus 6B equal to 1. Now then this one, B equal to C. So what we have this minus A minus 2B minus 2B, so this is equal to 0, and this gives you minus A minus 4B equal to 0. So not what we have, that you just subtract, add to all these, then this will be 0 plus 2B equal to 1, so B equal to minus 1 by 2. You will get B equal to minus 1 by 2. B and this we have now B, now this C. So the B equal to minus 1 by 2, so C is also equal to minus 1 by 2. Plus 2B equal to 1. B equal to minus 1 by 2. Or, and this B equal to C, so we will have this C equal to, this is also minus 1 by 2. And then B and C are known to us, then put this either in this factor or in this factor. If you put this B equal to minus 1 by 2 here, then you will get that this is 1 by 2, so this is now 1 by 3, minus 1 by 3. This is along this side, so A equal to 4. A equal to 4. Now what is wrong here? And this is now minus b plus c. A, this is now your a, this is now your minus 2b, this is now your plus 3c, and t, this is now minus a, minus 2b, and minus 2c. So b minus b plus c equal to 0, so b equal to c. Or a plus 3b plus 3c, this is equal to 1. And b, so a plus 3b plus 3b, so this is now your 6b. A plus 6b equal to 1. A minus 2b minus 2c. This is equal to 0, this is equal to 0. A minus 2b minus 2b, a minus 4b, this is equal to 0. Add. So this will cancel और यहाँ से आएंगे आपके minus plus 2b equal to 1. So b equal to plus 1 by 2. B equal to plus 1 by 2, so c equal to plus 1 by 2. And then b and c are known. Put it here. तो ये कितना हो जाएगा 3 और ये डल जाएगा तो minus 3. तो ये 2 आ जाएंगे. तो a equal to 2. A equal to minus 2. अब ये वैल्यू हम यहाँ रख दें इस जगह पर. Therefore, तो ये कितना हो जाएगा? देखिए यहाँ पर रखेंगे तो c पर पावर कितनी है 1/2 इंटू g पर पावर कितनी है b. तो b का मान कितना आ रहा है 1/2. अब c यानी कि e स्क्वायर अपॉन 4 एप्सिलॉन नॉट, इसका कितना आ रहा है -2. This is now your -2. A c raised to power a, ये -2, इसे ना -2. और b का मान आ रहा है b g पर है, g पर इसका मान 1/2. और c पर प्लस 1/2, c पर प्लस 1/2, 1/2. तो इसको क्या करें ना, इसको लिख सकते हो 1/c स्क्वायर इंटू स्क्वायर रूट g e स्क्वायर अपॉन 4 एप्सिलॉन नॉट. दिस इज रेज़ टू पावर 1/2. Raised to power 1/2. So we have the right answer is g e square. Now this 1/c square g e square upon 4 epsilon. Right answer is first one. So our answer is first. So this is the use of dimensions. By that you can find the right relation if you know the dimensional analysis, and you must be familiar of this one. So this is question number 19. Now the question number 20. Now all these questions are based upon the physical or the mathematical calculation. Question number 20. Question number 20 is that two cars moving in opposite direction. Moving in opposite direction.
opposite directions approach each other. Approach each other with a speed of speed of 22 meter per second and 16.5 meter per second respectively. The driver of first car blows a horn having a frequency of 400 hertz. The frequency heard by the driver. The frequency heard by the driver of second car. By the driver of second car is, and here is given the velocity of sound. This is now 340 meter per second. Now first option is your 350 hertz, second 361 hertz, and third is 411 hertz, and fourth answer is 448 hertz. This is now given the options. So now you can find the solution of this one. You know about the Doppler's effect. Both the source and the observer are coming close to each other. They have their own speed, and one of them, this source, the first car, you given the driver of the first car blows a horn having a frequency of so much. So real frequency is so much. This n is equal to 400 hertz. So this is now source. First car is the source. So the speed of the source is V0 equal to 22 meter per second, and the Vs, this is now your Vs, this is now your observer. Observer is moving with this speed. This is the speed of the source, this is the speed of observer, 16.5 meter per second. And you have to find the apparent frequency. What will be the apparent frequency? N dash equal to n into V plus V0 upon V minus Vs. This is our formula. So this we have this 400. This is given to n equal to 400. This is now 340 plus V0 is 16.5 upon 340 minus 22. So this is now your 400, and if you just, this is now your 356.5, and this will be your 318. So if you divide and multiply, then you will find it to be 448 hertz. This is the apparent frequency.
that will be heard by the driver of second car. So our answer is what? 448. This is now your 4. So these are the 5 questions of NEET 2017. So you all like, share and subscribe, and thank you to all of you.